Okay, John Kutsch
So,
is on the line, and we are recording a podcast for our audience. This will be posted both on Copenhagen Atomics channel and the Thorium Energy Alliance channels. And it's about where Thorium Energy is going to take us in the next 10 years or more.
mhm.
Um, so, John, what is your take on what has been happening in the last, I would say, the last month in nuclear energy?
um, the last month uh, for thorium, from where I'm at, and you can tell me to scratch it, get your, but from where I'm at, thorium somehow ARPA-E, the Advanced Research Projects Agency in the United States that is focused on energy, that's the E. They are still stumbling along somehow through this new paradigm we're in. And the thorium is still being funded. The policy at the Department of Energy is still to support funding of thorium and research and just plain old getting to do the research with thorium, which is a huge sea change. Before, thorium was considered second run fuel at best. It basically said if they only wanted to fund uranium-based products or plutonium because it was a self-referential thing. People use uranium, therefore we fund uranium, and they realized that that was an unfair, stricture against thorium. So that's just in the last month we found out that there's some funding and some availabilities, and just the general attitude has shifted. DARPA, the Defense Advanced Research Project Agency, has just opened up funding for uh, advanced energy sources, direct conversion of nuclear energy into usable energy. And they've accepted some thorium-based research proposals that we've sent to them. So that's been very interesting. And then the number one project that Thorium Energy Alliance is involved with right now is standing up a company called the Thorium Products Corporation. And Thorium Products Corporation will own a license that allows us to accept thorium, manipulate it, change it, make a different thorium-based chemicals out of it, and sell it to off-takers who want to use it for fuel and other applications.
I do want to remind the audience, maybe not all of them know sort of the physics difference between uranium and thorium. So obviously, most or all of the reactors in the world today they run on uranium 235, and most of those reactors need enriched uranium 235, and uh, and so you cannot burn all of that fuel. You can only burn some of it, and then the rest is called waste. It's not really waste; it's spent fuel or slightly used nuclear fuel. It can definitely be used some more, but sort of most reactors in the world today they have a burn up of something like 40 to 60 gigawatt days per ton of uranium, and that's per ton of enriched uranium that you put in there. Um, and the you can look up the price of enriched uranium, and I'll try to share just a screen with people here. Let me see. Is anything coming up on your screen now?
It says you've started to. Oh, there it is.
All right. So this is one of these websites where you can look up the current price of enriched uranium. And in this case, I've just set the enrichment to 19.8%, which is HALEU. And it says
Oh,
down here that at the current uranium market spot price, this is $18,000 per kilogram.
wow.
I do believe I set it to kilogram. Yeah. Otherwise, sometimes it's in pounds, but um, yeah, and actually, so the uranium price was quite a bit higher just half a year ago. So it has come back down, but of course the enrichment is still expensive. Um, so that's just for people to know what is the price of enriched uranium. And many of these reactors out there, they need 200 tons of uranium just to get started. So of course it's not cheap
Wow.
to load a reactor with enriched fuel. I would say though, now what I had there on the screen was 19.8%. Of course, you can change it to 3 or 4% or whatever your preferred light water reactor uses. And then the price is less than half of what we saw there. But in comparison, 1 kilogram of thorium only costs roughly $50, and it doesn't need enrichment. But of course, thorium is a fertile fuel, whereas what we were talking about before, uranium is an fissile fuel. So I mean, they don't compare directly, but I think this is one of the things we need to talk about today.
Thomas, I think your best metric, and the one that I use now because it is so shocking, is that even though there's something on the order of 4 times more naturally occurring thorium in the Earth's crust than uranium, that's misleading in that there's thorium is 100% usable as a fuel, where maybe what 0.5% of naturally occurring uranium norm is usable on average. There's some richer areas and less, but so your metric of there's 2,000 times more usable thorium on Earth than there is usable uranium. And that should wake people up. Whenever I get people saying, what's the big deal about thorium? Why would we want to use it? And I'm like, because it's 2,000 times more available. You get it for free when you process rare earths, which we desperately need to do in the West. And we could go down that memory lane of all the reasons why thorium is a superior material, that in a way we have no choice but to use it, because if we want to get back into critical materials, we're going to be creating a large amount of actinides. Now we have a way to get rid of the uranium that comes out of rare earth production, but we better come up with a way to deal with the thorium. And if all we do is think of like ways to store it, that is an utter lack of imagination. We're spitting in the face of God himself, who gave us this energy source that could power, humanity for thousands of years. And so, on a very cogent point, the national security interests of the Western world and the economic interests of the Western world, our adversaries in the world are going to use this material. And if they are creating electricity and heat for a penny or 2 per kilowatt, and we are stuck making power for 8 or 10 cents or 11 cents or 100 cents a kilowatt, we're going to be a second or third world country, and sorry to
I don't want to
digress.
make it so draconic, but let's keep it light and say that there's these different options, and whether people choose to use those options are basically up to them. I mean, you and I are, of course, working towards getting thorium as an active reactors that are using thorium, so that we can create energy from that. We know that there's other good people out there also working on that. But I just want to come back and talk about those numbers. So we already talked about the fuel price. For thorium, it's $50 per kilogram, and actually for that $50, you can get 22 point something, let's say just 22 gigawatt hours per kilogram of heat out of that. If you take enriched uranium, let's take just the regular run-of-the-mill of 4% enriched uranium that they use in most of the light water reactors today. In that, if you have a 60 gigawatt day burn up in that reactor, then it's roughly 1.4 gigawatt hours per kilogram. So 15 times less per kilogram of uranium. And then on top of that, you have that big price difference that you talked about. And on top of that, you have that availability you talked about, that there's thousands of times more thorium than there is uranium. So there's a number of things that makes thorium a better fuel.
Yep.
On the other hand, so if we go back and look at thorium reactors, you can make these molten-salt reactors that are actually not that big, because they don't have this high pressure, and they have a better neutron economy. So the size of the core is much smaller, and therefore they need much less material to build that reactor. So the cost of the reactor is also much smaller, in the order of 10 to 100 times smaller than for a light water reactor with the same output. So there's very large savings on the reactor as well. And thorium is the only fuel, it's the only fertile fuel that can create a breeder reactor and thermal spectrum. And because it's a fertile fuel, you need to have a breeder reactor. Otherwise, it doesn't really work. And that is why putting thorium in solid fuel reactors, which have been done many times in the past, doesn't yield all these positive benefits that we talk about here. You basically need a molten salt reactor to release all those positive benefits. And then on the other hand, of course, you can use uranium-238, and there's been many projects in the past. More than 20 reactors have been built where they tried to use uranium-238 or depleted uranium or natural uranium, whatever you want to call it. And for that to be a breeder reactor, you have to do it in fast spectrum. And what those more than 20 reactors from the past showed is that it's not easy. I won't say that it's impossible. I think it is possible, but I think it's really difficult. And I know that there's a number of companies out there trying to close the fuel cycle with a fast reactor. And eventually we will see if it works or not. But while we're waiting for that, my personal opinion is that there's lower risk in betting on the thermal neutrons or slow neutrons fuel cycle, because it has an inherent stability around it, and the likelihood of something causing problems is much smaller. I mean, if you look at it, so back when we were still using horse carriage, we were able to build thermal cycle nuclear reactors with very, very simple means. That's back in the 40s. And since then, we've built hundreds. If you include the military reactors, I think we are close to 1,000 reactors that we built in the thermal fuel cycle. And literally all of them worked. I mean, some of them might have a few hiccups, but literally all of them worked. And then we have built sort of a couple of handfuls of fast reactors, and literally all of them failed. I mean, there is a fast reactor running in Russia.
The BN800 is
but even the Russians admit that it's more expensive and not easy to run. I mean, they prefer their light water reactors over their fast reactors. So
that's exactly right. I mean, we are eminently optimistic people when we, but we're also realists. Like, I think the people get too involved with like the reactor and the cool things in the science project, and they don't reduce it to like, well, is this going to make me electricity for a penny a kilowatt, or thermal energy for a penny a kilowatt, and electricity for 2 cents? Because that's coal, right? And we have to beat coal. And I believe we can beat coal. We've been able to do it for 50 years, maybe 75 years, depending on, when you put the flag in the ground of, commercializable nuclear power. And, you've done that great. Copenhagen Atomics, it's why I believe in Copenhagen Atomics, because it's based on economics and material usage and availability. And, some of the reactors out there, and we can talk shit about some of the competitors. You probably don't want to do that, but there's some competitors out there that are just basically a step above a science experiment, and their use of fuel and the creation of waste and the complexity of their systems is laughably astounding, and it's like, what is their cost per megawatt? And they couldn't tell you, because they don't care. They just want to make a reactor and get government funding. But this is my admiration for Copenhagen, and I'll show my cards. I believe in what you're doing, and that's why I'm on the podcast, because it is the one of vanishingly few Western world reactors that could actually be deployed. I think, I'm more optimistic than you, buddy. I think there's no reason you couldn't turn one of yours on in a year. If it became a priority for policymakers and funders and people who can supply you the materials you need, the restricted or, controlled substances, whatever, but I believe you could do it. I seen your system, and it's a runner,
Mm.
whereas other people have PowerPoint presentations.
True. So maybe we should just explain that a little bit to the audience. So, yeah, Copenhagen Atomics have built two full-scale test reactors already. Those cannot start a real chain reaction, but the third one that we're building now, maybe it could, but number four definitely can. And sort of the way we build these reactors is we order all the components from existing suppliers in the steel industry, and currently we don't ask for N-stamp, approvals or anything. We just buy regular steel, stainless steel, and so on. And it's not very expensive. I mean, the whole a whole test reactor without fuel, just the steel and the pipes and all that stuff, costs roughly $6 million. And I mean, when you look at some of these other reactors, it's because there's not that many tons of steel there, and it's common steel, it's common stainless steel, and it's heat exchangers that are off the shelf and so on. And we built the pump ourselves. If you,
Does 6 million include the labor to assemble it?
Yeah, yes, it does, but
Oh,
it doesn't include the fuel salt. But
sure.
if you look at for example, the Hinkley Point C is sort of the one reactor right now in Europe that we are building. I last time I saw an article that it's the current estimate is that it will cost 62 billion US dollars to build those
Wow.
two units. And I looked up, so they publish how much concrete and how much steel they use for this project, and how much uranium they need to fuel it to load. And if I look up all those numbers, what it cost, like all those raw materials without nuclear licenses, of course, just the what steel and concrete cost and nuclear fuel, it's sort of less than 6 billion US dollars. And so I don't know if you noticed, but Elon Musk has this idiot index where he says, what is the price of a product versus what is the
Right.
cost of the raw materials? And you can see here right away that the idiot index of that reactor is sort of a factor of 10. So you pay 10 times more for the reactor than for all the raw materials needed to build that reactor. And uh, I think we can do better. I think all the nuclear industry and the people designing reactors should aspire to do a better job. It would be great if we can get it down to sort of two times, so that the reactor, including fuel and everything, is twice as expensive as the raw materials. But of course, right now we are not there with all the cost of licensing. But we can come back to that. I don't want to go into all the licensing costs right now. Um,
Well, we could glance at it. I think it's important because you probably have smarty pants. If somebody's been listening this long, depending on how you've edited this video, if if somebody's been listening this long, they're either fell asleep or they're drunk or they actually get what the what we're talking about. Uh, and I think one of the great things about the Copenhagen reactor, um, I think you either should go relatively big for your economy of scale, but what you've got is something that's you know in a smaller package, so that once you get, I'm going to be USA centric here. Hopefully, if the NRC approves the system, they also are going to introduce, fingers crossed, that N of a kind, just like every airframe isn't, licensed one by one by one. If you can get your system licensed, then you can make 1,000 Copenhagen reactor units, or 300 or 100 or 50, and no one unit having economic failure. Something bad goes on. Somebody forgot to tighten a hose clamp and the pumps, empty the nothing. You don't have an event there, right? You have a broken egg inside a container that can't get out, can't go anywhere else. Nothing's mobile. You're not, fission stuff and products and gases aren't going anywhere. It's a nice system from that aspect, and that there is no one, and there's no credible case where a bunch of Copenhagen units would, pop their lids all at the same time. even a missile strike, right? Wouldn't take out more than one or two of your systems. So I think that's an admirable aspect of your system deployment design. And it also allows an economic deployment. If you deployed 20 of these, then later on you can deploy 20 more and then 20 more. You can, instead of doing 1,400 megawatts all at once, 3,600 megawatts thermal all at once, you're doing a couple hundred, and it makes it a more economic proposition, especially for developing industries or developing countries. That'd be very inspiring for a country like Indonesia
Mm.
that I know you have a relationship with, and I think that's one of the most admirable design aspects of the way you want to deploy your system.
Yeah, and that I mean the we referred to this Hinkley Point C before. Those projects are so expensive that it can only happen if you have government sponsors. But if you have these type of reactors like we have, where you can get started for $100 million or something like that, then it opens up to a much broader market, and we can make the nuclear industry more funded by private individuals and private companies. We don't have to have all these political agreements and political funding. I think it really opens up for many more uses of nuclear energy, especially in the industrial sector. So it can be used for hydrogen and ammonia and steel production and
Yep.
cement. Maybe someday cement is a little bit more difficult, but aluminum and all kinds of chemicals and oil refineries. I mean, there are so many industrial applications, and if you look at the total market of those industrial applications, that's actually a bigger market than the entire global market for electricity. So it's a huge opportunity to sort of power that in the future. But I also want to talk about the data centers. We talked about a little bit before we started recording, and something is happening, of course, especially this year with data centers. I especially want to talk about this tweet or thing last week from Elon Musk, where he said he was thinking about how he could stand up 1 terawatt of energy or 1 terawatt of compute in a data center. And just for the audience, 1 terawatt is sort of all the electricity is in North America, plus all the electricity in all of Europe, and then some. So it's a if you look at all those, there's hundreds of companies, maybe even 1,000 companies supplying electricity in North America and Europe combined, and he as a company or would potentially become a bigger customer than all of those. And I think the only way he can do that is if he gets involved in supply chain. But let's talk a little bit about how that could be done, because obviously it's not going to be only thorium energy or only solar panels or whatever. It's going to be a mix of different energy sources.
Well, the uh, his when he talked about that, he was talking about data centers, which we in I have a feeling myself, and I was talking to some of the Google folks that do their data centers. They're the original data center centric company, and then we were talking to some of the cloud-based companies, AWS, Amazon Web Services, and I was like, is it really going to be like that? Because if we have artificial intelligence, our brains up here use about 40 watts of power. So, and they're okay, they're not supercomputers, but they're kind of computers. And 40 watts, and we have a pretty good cooling system, and we can work in pretty harsh environments. So I have the feeling that artificial intelligence, if it's really intelligent, is going to be able to design, itself and optimize itself. So I think in the future, the data center power consumption would be mainly from using it more. And it might cancel itself out. The more we use it, the better it gets at being efficient about being used. And we're stupid monkeys, so we're just going to keep asking the same goddamn questions over and over again. So it's going to be like, oh, I know the answer to that already.
Just
I don't have to.
guess the answer and use it
Yeah,
again.
it's just going to look up in the little file system and be like, here, I've answered that 7,000 times already this hour. Um,
Yeah.
I think the real deploy, and I'm sorry if if you're like, God damn it, Coach, follow the script. But like I think the real part to me that motivates me to a huge extent is where you can use Copenhagen Atomics system in ammonia production, uprating petroleum, creating synthetic petroleum products and greases and jet fuel, things that we absolutely cannot replace, not in the foreseeable future, maybe not ever, ever. You're not going to get me on a battery powered 747. All right. You can fly that. I'll meet you in New York, and hopefully you get there, or I'll throw some flowers in the Atlantic because you're going to run out of power about a third of the way into your trip and you're all going to die. So we need, we have these chemical storehouses of energy that are phenomenal, but to make them economic. And I was looking up here on one of my other monitors to see if I could find, but right now, the electrolyzers we're looking at Thorium Energy Alliance are getting down to 36 kilowatts per kilogram of hydrogen. And if you do a little math there, the holy grail for hydrogen is $1. Henry Hub in the Gulf of Mexico, America, whatever we're calling it these days. Henry Hub in New Orleans and Houston area is $1 on average, depending on what natural gas is doing. We could make, if we're making hydrogen for 37 cents, 36 cents a kilowatt, and we're only paying 2 cents per kilowatt, we're at 72 cents a kilogram right now. Put some overhead in there and some water processing, because that's where you're going to probably get the hydrogen from, by cracking water, but you're under $1. So we've done it, and you're under $1. Here's the magic that everybody forgets about. Nuclear makes power very boring because it's going to make that power at the same way, at the same cost, at the same output for 80, 90, or 1,000 years, forever and ever. And so that's called beta risk, price risk. If you tell any product planner that you can tell them what they're going to pay for their energy inputs a decade from now, tears of joy would run down their face.
Yes.
They would cry in your arms, and they would literally be willing to pay twice the base price for the energy just to have product stability. Because right now they're being whipsawed. 50 cents a million BTU one day, $15 the next. Literally, it could overnight like that. But if you told them 97 cents a kilogram for the next 40 years, it's the miracle of miracles, and data centers would benefit from that too. Nuclear energy is the most boring energy you can possibly imagine. And I am convinced, I'll put on my tinfoil hat here, I'm convinced a lot of people don't like it because they love arbitraging energy. They love seeing that a pipeline break and they can take a bet against natural gas, or they see the weather's going to suck and they take a bet against solar, or they see that like there's a wind drought in Germany and they take a bet against wind. There's no betting against nuclear. Nuclear works in the shittiest weather and the nicest weather. It works 24/7, 365, and at the exact same price. It's the most boring stuff in the world when you get it to work. And that's why the arbitrage community does not like nuclear. So I firmly believe that I make a big argument, and this is like another topic, but anything synthetic will always eventually be better and cheaper than the natural analog. So synthetic diamonds are better and cheaper than real diamonds by a lot. And synthetic, just go down the list. At some point, we're going to crack the code on synthetic blood. And if you ever go into an operating room, and they go, would you like blood from a drug addict that needed to get a fix, or would you like this synthetic blood? You're going to be like, give me the synthetic blood. Same thing with meat. I mean, I don't have anything against eating a dead cow. But, synthetic meat has the advantage that it doesn't have E. coli or listeria, and, it's prepared in a super ultra clean facility, all that. So, and you could go down the list. Synthetic oil made from natural gas is much better than fossil derived, normal fossil derived oil. The synthetic wood, plywood is far more usable. Anywho, so I think electric uses for like making hydrogen as an interstitial energy, whether it's ammonia or straight hydrogen for things like direct reduced iron, we're going to lower the cost of iron and steel, and it's going to be better. We're going to have cheaper, better steel, and we're going to have cheaper, better petroleum products, and we're going to have cheaper, better plastics. And now I'm sure there's some green people out there who like tears of blood are running down their face saying, no, we can't have any more of that. But everything around you is plastic or synthetic chemicals. Our entire life today. Now, that's probably causing havoc with our endocrine systems, and we need to solve that, in terms of like artificial hormones and things like that that come from plasticizers. But the fact is, from the paint on the wall to the clothes on your back, everything in our lives is plastic or synthetic chemicals, the medicine you take, and we can make them better and we can make them more. But if we do it with nuclear power, essentially, we're taking nuclear power and freezing it in the form of your plastic cup. We're taking nuclear power and freezing it in the form of aluminum and steel. But you're not going to make steel, aluminum, grease, medicine. You're just not going to do it with solar and wind. If you want to use solar and wind for your, occasional daily use or to keep your street light in the desert running, that's great. Good for you. You get a gold star for your green cred. But I want to lead a life of greater prosperity, and I want another 8 or 9 billion people in the world to live lives of, energy abundance and energy prosperity and energy opportunities to create new jobs and new technologies. And that is the exact opposite of what's going to happen if we try and run industrial societies off of so-called renewables. We are going to deindustrialize. We're going to close ourselves in. We're going to limit what we can do with ourselves. And
You're taking all the You're
China and
taking all the
India.
words out of my mouth. I mean, it's exactly what I'm saying about the industrial sort of second or third or fourth or whatever revolution. And I completely agree with you. So in the last 100 years, we have increased the amount of energy available to humans by a factor of 10. And in the same 100 years, we've grown from 2 billion people to 8 billion people. And and a lot of people, and every time I talk to people, I discuss with them, what do you think is going to happen in the next 100 years? And a couple of years ago or 5 years ago, there was actually quite a lot of people who said, it's not going to grow that much. Maybe, maybe if it's crazy, it's going to double. And some people back then said, no, it's going to go 10 times in the next 100 years, just like it did in the last 100. And I've always been a firm believer that it's going to go 10x. But now with all this hype about data centers and AI and so on, there's people that I talk to, investors and other people that are starting to talk about 20x or 30x, and
Yeah.
and I think it's very interesting to do the math and the physics behind that. Forget about politics and how much money you need, but is it actually possible from physics to generate 10 times more or 20 or 100 times more energy?
Oh,
And clearly, it is possible to generate 10 times more energy in the next 100 years, but it's not going to be from wind and solar. I mean, I'm sure we're going to have some wind and solar, and let's just be very friendly to wind and solar and say that maybe they can take 10% of that. So in the future, maybe wind and solar can take 10%. So that's 10% in the future is all of the energy in the world today. Right now, today, wind and solar are taking sort of, I don't know, between 2 and 5% of global energy. And if they have to scale that to 100% of today, that is definitely going to take them 100 years. And we talked about Thorium Energy. I've said many times that I think Thorium Energy is going to provide half of all energy when we get to year 2100, so 75 years from now. And many people say, oh, but we don't even use it today. How do you think it's going to scale and take half of it? And I say, because price is king. And that's also what you said in the beginning. I mean, if we can get the price far enough down, we
Yep.
know that there's plenty of thorium, and we know that we can build these reactors and assembly lines. We could easily make 10,000 or maybe even 100,000 reactors in 1 year. So it's going to be all over the place, and we're going to
Yep.
have so much energy for all the products you talked about before, all the synthetic products and all the services we want to use, whether it's self-driving cars or AI or Optimus
Yeah, and
robots or
you don't even need to like the self-driving cars and AI and all that. That's us, Western world. There's only a couple 100 million of us. There's 7 or 8 billion people who live some form of energy poverty. So what if we brought air conditioning and refrigeration to the 4 or 5 billion that don't have it? That's the power suck, not some data centers, let me tell you, water treatment facilities for 4 or 5 billion people. But here's the super optimistic great news is we could generate that 30 times more energy for 9 or 10 billion people, less damaging. We can walk lighter on the earth by generating it with 10,000 nuclear reactors, or I should say, we could easily install 5, 10,000, 1,000 megawatt installations. If each installation, however you divide it, your reactors are incrementally a little smaller. I'm a big fan of big reactors too. You want to build some AP1000s, super awesome, good for you. If you want to build some CANDU reactors, whatever the mix is, if we generally are making a gigawatt, we can do that easily. I mean, the Chinese built 1,000 coal plants in 20 years, right? We did too. There used to be 3,000 power plants in the United States. So we did it. When we talk these numbers, people are like, oh, thousands. It's like, that's the scale. So we need to make 10,000 reactors every 20 years or so if we want to transition the world from the most dangerous, most expensive, erratic, hard to get to, damaging energy to something that opens up a world of opportunity while making it possible to live on this earth without absolutely consuming it and choking ourselves to death. I mean, it's Pollyannish. That's like I'm a super optimist. I think we can cure the world and lift people up and provide opportunity and abundance to humanity. And I was going somewhere with that, but
yes. So I think it's coming now. I mean, we've been waiting for this for a long time. I talked about this almost 20 years ago, but I think actually I sort of when I look in my crystal ball, I see it happening within the next 10 years. I think especially in the US, I think US will be a first mover. I think that the total amount of electricity produced in the US will likely double in the next 10, 15 years. I'm saying 15 because what is holding it back is sort of the regulations around nuclear, and we need to solve that. And we need, I don't know, I hope we can use the AI to figure out how to get around this regulation because that's really what's holding it back. Back in 1943 or 42 or 43, we built very large reactors. So that one of the Hanford reactors is a 2.5 gigawatt thermal installation, and they built that in 11 months and it worked for 25 years without any accidents or anything. I
yeah.
mean, and back then some of the components were delivered on horse carrots. I mean, of course we can do it today. I mean, there's no doubt about it. Engineers can easily build thorium plants and assembly lines that can make 100,000 reactors. And of course, there's going to be some resistance to making the grid. I mean, upgrading the grid. But I think if we upgrade all the existing grid lines to carry 5 times more electricity, I think that's probably possible in a lot of places.
Oh,
Putting
let
up
me
new
tell you.
cables, increasing the voltage and stuff like that.
Yeah. Well, you're, my hero and your dog, Alvin Weinberg. you know, he nailed it, a pot, a pipe, and a pump, and give me a reactor. Simplicity is safety. And we light water reactors, in a little brief side note here, they're complex and they have quadruple redundant systems because they're always ready to run out of control, right? That's why you need control rods and shutdown rods and quadruple redundant pumps and valves for everything. Whereas molten salt reactors and Gen 4 reactors are inherently safe. Like you pick one, pick a lead cooled one, pick your reactor, pick any, and the nature of the reactor, the number one aspect is they shut themselves down, right? They have a dead man switch. So that's the great optimism there is like, why can we make 10,000 of these things? Oh, we don't have enough people. Where are we going to get all the operators? Well, we probably won't need the same amount of operators to operate them because if we walk away, if there's a zombie apocalypse, they're just going to coast down to like self-store, situation. And, it all came back into my head. I don't have Alzheimer's, Thomas. I have Someheimer's. So, 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 so I remembered what I was going to say. And the thing about thorium is that unlike uranium, thorium has thousands of industrial uses. And how are we going to transmit 5 times more energy through the same wires? Well, maybe not 5 times, but I know one of the research projects that we initiated with ARPA-E last year was thoriating aluminum and copper. And thoriated copper can transmit electricity the same way silver can. And thoriated aluminum can transmit electricity at the same rate that copper can. So we don't have enough copper on this earth. So how do we extend what we have? Well, we use it by adding 1 or 2% of thorium to it. And now magic occurs and we can suddenly, we've essentially doubled the amount of copper just by adding a de minimis amount of thorium to it. And there's all sorts of thorium-based solutions like that. The greatest optics in the world, so our lasers and our fiber optics can become more efficient if we just thoriate them. The clarity of the glass, would enable us to have more efficient communications, on and on. I won't bore the audience, but the highest temperature ceramics on Earth are thoria. The scientists out there know that when you pick up a crucible, it's alumina a lot of times. Sometimes you get a platinum crucible, but if you want a really badass crucible, you find somebody from Russia willing to sell you a thoria, and those thoria crucibles are the highest temperature ceramics ever created. And there's some reason to believe they're the highest temperature that can be created. They're the space shuttle tiles, right? They're the linings of jet engines to this day. People don't like to talk about it, but every microwave, when you go to heat your coffee, you're heating it with thoriated magnetrons. So thorium's great, astounding ability of our favorite little atom is that it acts like a refractory metal, a platinum group metal, and a lanthanum group metal, which is rare earths. It has natures of all of those. And that's why I love this. It's such an unbelievably missed opportunity to utilize this material. And so just besides the fuel, the material uses of thorium are astounding.
Yeah. And I'm very happy that you bring this up because we also need to spread that information. If we look back in history, there was a whole century that was centered around making steel. So the steam engine and the high-rise buildings. And then the next century was centered around making computers and radios and mobile phones. So the Silicon Age. And I think this century is going to be all about thorium. I think that we will be able to show that we can generate half of all energy in the whole world from thorium, and all these different materials you talked about will also make the world a better place.
Yeah, I mean the material uses of thorium, I think you're right about the century. It's going to be an energy century, right? We've we've figured out how to build massive buildings and bridges and stuff. We know, we had a history, not so much lately, but we had a history of doing mega projects. We can engineer the earth in smart ways, to hopefully accommodate people and make animals and nature and stuff live in harmony, man. You know, I I want all that, and I think it can be done, and we can do it without it being like you know, 2049 apocalypse hellscape nightmare. It's not going to be Mad Max. It's going to be future, it's going to be the Tomorrowland, well, those are our two choices, really, right? I mean, I believe we can do Tomorrowland just as likely as we could do something where we decide to collapse society, which would be, it'd be the dumbest decision. We're hairless apes, so we're good at making dumb decisions, but you know,
So we have to realize, we saw this during COVID, that there are some people who have a sort of a mindset that they like to be told what to do, and they like to have a sort of a box kind of, they have to live their life in this box. And there's people who like that, and I think they should be allowed to do that. But there's also other people who needs a bigger box, a bigger playground, and I think we can accommodate both of those types of people in the
yeah,
future. And I think whenever somebody gets in a bad mood or depression or whatever, they can ask the AI and say, I would really like to try something new. And then the AI can teach you how to make poetry or play the guitar or whatever. And, when I was a kid, it's very fun to learn all these new things, play the piano or whatever. So I think a lot more people will use the AI to teach them stuff. And I already see my kids, they, don't want to go to school and sit at a university lecturing and have to read like a book. They just ask the AI and then they get feedback, and it's a much better way to learn.
yeah, and well, what your European experiment has to teach the world is, you know, if if you give mothers and fathers time off to be with their kids, or the availability to, work and be with the kids at some reasonable amount, and they're not worried out of their minds about what if their kids are going to have something to eat and whether they're going to have a place. United States can be a very, very rough place to be a young family, and they wonder why, like, oh, we don't know why no one's having any kids. Are you insane? It's the most frightening thing you could imagine. It's an 18-year prison sentence. That's how people look at it. Like, oh my God, I've got this 18-20 year prison sentence, ball and chain. If you had energy abundance that led to opportunities and employment, and gave, if there was so much abundance that people had the ability to, do the job of parenting, we could shut down half of the prisons. United States, is its own example of, we've incarcerated way too many people, and we've essentially lost we've lost the plot. The idea should be, we shouldn't need prisons because we're the land of opportunity and milk and honey and all that. So why is it such a, rough place to grow up as a child? I think we could, I don't know if we're wandering off the reservation there, but energy is life, right? I mean, if you stood up right now, I bet the back of your shirt would say energy is life or prosperity, and that's, there you go. See, I know it. We didn't
Yeah.
even practice that, but it's true. And so that's why I argue endlessly with everybody that energy is everything. It's civil rights, it's the legal system, it's water, it's medicine, it's transportation. There is nothing that doesn't start with energy. Energy is the uber alles, it's the alpha and the omega. If you have energy, poverty is the worst thing in the world. It's slavery, it's, abject, misery, and energy abundance is freedom to do, and the ability to choose what you're going to do in life. So that's why I'm so keyed in on this. It's not that I got well, I do have a special heart place in my heart for thorium and everything it can do, but you know there's, as you brought up earlier, there's spent nuclear fuel, there's plutonium. We could repeat the old American program of swords into plowshares, where we took the Russian bombs and turned them into fuel. 10% of all the energy in the United States for 30 years came from dismantled Russian nuclear warheads. It was the greatest peacetime thing ever. So, anywho, I'll just shut up.
Yeah, but I absolutely agree with you. I mean, I usually say that the oh, sorry. I usually say that the energy is the fundamental building block of a prosperous society or a great society. And people who want to tax energy are out of their mind. I mean, it's like taxing the most important tool to make a great society. You know, you're crazy. And I agree with you some of the things you said about the US and Europe, but definitely in Europe, and there are some crazy people who are taxing energy. It's like when they do that, you know right away there's no intelligence there.
Yeah.
But hopefully we can fix that. And I totally agree with you that you and I are really good at engineering and building stuff and getting it to work and stuff like that. But there's lots of other people in society who are good at solving those sort of social problems. You talked about imprisonment, and there's many other problems that need solving. And I really hope that we can free up people from having a stupid job in some office somewhere where they're typing on a Windows keyboard all day long. I mean, they should be working on fixing some of those social issues that we have both in the US and Europe. They're just different issues. And then we should stop taxing energy and make a lot more energy, and also make sure that not only Europe and US has access, but also Africa and Asia and everywhere else.
Yeah. As the second we make nuclear power cheaper than coal, and this might be a reason why, it's got a lot of boat anchors attached to it and makes it very hard to license and things, because a lot of people's ox is going to get gored if this happens. It's not an if, it's when. China is doing it right now. Our friend Kun Chen is, working on different projects, and the CNSC is, if Copenhagen doesn't get it done, it's going to get done, and I would like there to be a Western option, but power cheaper than coal is always going to win because it's an economic decision. China and India and Indonesia don't burn coal because they love burning coal. They burn coal because it's the cheapest option to pull their people out of poverty. And if we can give them 100 times better option, they would flock to it in 2 seconds. It is the ultimate nuclear fuel because it is eminently non-proliferating. So it is the fuel you could trust to put in Gambia or El Salvador or Mexico, or pick your country that you're worried about. Well, they're unstable. Well, then give them a thorium reactor and let them run free with it, and maybe they'll become stable. Maybe their opportunity that they'll become an asset to the world instead of a pariah. We should be sending thorium reactors to Iran. To pick your state that has a something problematic that you don't like, and they're the ones that need energy, more than anybody.
But you're absolutely right. I mean, I agree with you. There's going to be a lot of countries with thorium energy, and they are going to sell energy to their neighbors. There's also the fact that if we look at the world today, 60% of all steel in the world are made in China. Why? Because coal is so super cheap in China. And also China is the world's factory. They make a lot of the other products and export them all over the world. I think in the future, the countries who have lots of thorium energy, they will be making steel and cement and aluminum and
Sure.
copper and all these other products, and they will be selling those products to the countries who doesn't have it. And then the countries who do not have thorium energy, maybe they are very good at tourism or building boats or making poems or singing songs or whatever.
Well, I think like uh in I think actually if we provide energy to the world, things like manufacturing will become hyper localized, and we'll, through rapid prototyping or additive manufacturing and lowering the cost of high quality steel production and aluminum production and whatever else you need, there could be an Indonesian car industry. There can be a Brazilian computing, and they can have their own, their country, just like food.